Okay. So can you see my screen now?
Yes. Go ahead.
Good. Thank you very much for inviting me. I will give a very brief review of the Chang'e missions. So usually it's very difficult to pronounce the name of the Chinese Chang'e mission. It's not changed, but Chang'e. So what is Chang'e? Chang'e is the Chinese goddess of the moon, and she flew to the moon. You may notice that there's a rabbit with her. The rabbit's name is Yu Tu. So it means jade rabbit. We will talk about jade rabbit later in this talk. So let me introduce the Chinese Lunar Exploration Program. The symbol of the CLEP shows on the screen, and the Chinese calligraphy of the character of the moon. You can see it looks like the moon, and at the start of the symbol is the Chinese dragon, long's head, and the tail is consistent with doves of pieces, indicating China's peaceful use of space. The footprint is the symbol of human exploration, so that's the symbol of Chinese Lunar Exploration Program. So for the first stage of Chinese Lunar Exploration Program, it consists of 3 phases. First is orbiting, and then landing, and the third and the last is sample return. So back in 2007, China launches its first lunar mission, Chang'e 1, and it followed by Chang'e 2 at 2010, and landing at 2013, and the far side of the moon at 2018, and sample return last year, and we are looking forward for Chang'e 6 in the near future. So you may notice that Chang'e 2, Chang'e 4, and Chang'e 6, they are the backups of Chang'e 1, Chang'e 3, and Chang'e 5, respectively. So for Chang'e 1, it was in the orbit of the moon for nearly 500 days, and it controlled impact the moon on March 2009. You can see the trajectory of the Chang'e 1 mission. What science do we get from Chang'e 1 mission? We have a global mosaic with 120 meter per pixel resolution. It's a beautiful map, I will say that. Besides the visible image of the moon, we also get the topographic data of the moon. So in this map, it's a false color image. For the warmer color, like the yellow and the red, they means higher in elevation, while for the cooler color, it means lower in elevation. So on the moon, you can identify extensive numbers of impact craters, and there are smaller ones, there are larger ones. From this map, you can tell there is very large elevation difference throughout the moon. For Chang'e 1 mission, it also obtained several elemental maps of the moon. It includes silica, thorium, uranium, and etc. These maps tells you the distribution of different elements on the surface of the moon. There is one interesting instrument on Chang'e 1 mission. That's the microwave instrument. It receives microwave reflected from the surface of the moon. So from that information, we can know the surface temperature. From this map, you can see in the low latitude region, it's very high for temperature, but for the polar region, it's quite cool there. It's the first time we get a microwave moon using the Chang'e Mission data. So let's talk about Chang'e 2 mission. It was launched in 2010. The mission's goal is to validate some key technologies and obtain very high resolution image of the candidate landing area of Chang'e 3. So it obtained the whole lunar surface with image resolution of 7 meters. And especially for the northern Imbrium region, the surface resolution is 1.5 meter per pixel. When it finishes primary science phase, it went to the Sun-Earth Lagrange point and stayed there for 1 year. It encountered with interesting asteroid Toutatis and did some cool science for the asteroid. In 2013, as we all know, after 44 years of the lunar landing from last century, Chang'e 3 landed in the North Mare Imbrium, and the date is December 14th. And the next day, the rover was deployed and to drove on the lunar surface. Remember the name of the rabbit for my first slide? So the rover's name is Yu Tu, means jade rabbit. The lander and the rover landed on the rim of a 400-ish meter impact crater. You can see from the NASA's Lunar Reconnaissance Orbiter camera image that the Chang'e 3 lander and the Yu Tu rover and a very big basaltic outcrop. So on the surface, the rovers and the lander take images for each other. And the longest image in this slide indicates the basalt outcrop imaged by the Yu Tu rover. So there are a lot of scientific instruments on the rover, include a camera and a lunar penetrating radar, which tells you the subsurface structure of the moon. So using the lunar penetrating radar data, our team have identified several interesting layers beneath the lunar surface. That's the first time people have identified a complex volcanic activities beneath the lunar surface. So our results made on science. What's next? You may think it's Chang'e 4. So from the visible image of the far side of the moon, it's difficult to tell what is the difference in elevation. So from the topographic data, we can see there is a huge hole at the north pole, at the south pole of the lunar surface. So for this side, we are not be able to see them from the Earth because tidal locking. So in order to explore the far side of the moon, we need a relay satellite. So in 2018, China launched a relay satellite named Chang'e, and it built connections to the lander and the rover, which was launched in 6 months later. And in early 2019, it touched down on the surface of the moon. And it's an international collaboration mission. There are several Dutch and German instruments on the rover and the relay satellite. Before the mission occurred, we used remote sensing data to generate a local stratigraphic in the landing region. You can see there are several layers we identified occurred in different geologic time. It's really a interesting journey for the lander and the rover to touch down on the moon. Because of the time delay, the lander and the rover find a safe place itself and touch down in a crater named Fonkamen crater. After it touched down, the International Astronomy Union approved several Chinese names for the Fonkamen region of the Chang'e 4 landing site. The landing site itself is named as Santorio Tianhe. So the Chinese characters in this image shows the names approved. And you can see the lander and the rover. So this time, the rover's name is Yu Chu Chu. It means Jade Rabbit second. And you can tell from the image itself, the surface is covered with very fine materials, and it's different from what we saw for the Chang'e 3 mission. It indicated this region is a much older surface than the Chang'e 3 landing region. Thanks to the NASA Lunar Reconnaissance Orbiter camera, it monitors the Yu Chu Chu rover has been moving for several hundred meters since it touched down. The white arrow indicates the little rover. For some light condition, you can even see the tracks of the rover. On the end of the second day, the team identified a bench of rocks. Using the visible near IR spectrometer on the rover, we studied the composition of the rock, and we identified it as an ancient lunar crust. It's the first time we identified the lunar crust on the lunar surface. So next is the Chang'e 5 mission, which happened several months ago. It was launched in November 2020, and it got samples back to Earth on December 16, 2020. The mission is very complicated. It consists with descender and orbiter. The descender landed on the surface of the moon, and it takes samples from the surface and the subsurface. For the surface, it uses a robotic arm to do the sampling. And for the subsurface, they're using a drill sampling. In total, the mission returned 1,700 grams of samples. And after the sample accomplished, the mission returned to the orbiter, and it docked with the orbiter waiting there, and the re-entry capsule was released, and the sample returned to the Earth. So why is important for the Chang'e 5 mission and the new acquired lunar samples? The Chang'e 5 lunar sample may help us to resolve several fundamental important questions for the lunar geology. First is the lunar impact history. As we all know, the 6 Apollo missions and the 3 lunar missions their samples are relatively old. There is a huge gap between 1 to 3 billion years. So the Chang'e sample may provide important information for young basalt, which will tell us an intact history of the lunar impact history. In addition, there are no samples to tell the magnetic field of the moon from 1 to 3 billion years. So it will tell us more about the history of lunar dynamo. Third, since the basaltic material was formed by partial melting of the lunar mantle, so it will give us insight of the lunar mantle at the time of a very young age. Last, it will tell us more about a special kind of lunar rock named creep. So now our university have applied for the lunar sample, and we already got the samples back to our laboratory. Hopefully, we can get some interesting results in a few months.
Thank you. Thank you very much.
This is my last slide.
Yeah,
let me show
it's fantastic.
a video of the Chang'e 5 landing progress. And with that, I will be very happy to take any questions. Thank you.
Thank you so much, Jun Huang. Wow, it's a otherworldly moment, really, on the moon, and with all this explanation about the different Chang'e mission, and if you too, the jade rabbit, and it's incredible. What have you, well, it's difficult, it's enormous, but what have you personally learned? You followed a mission on Mars and on this Chang'e mission, different Chang'e mission on the moon. What have you learned from it, and what questions does it open, all these fantastic Chinese missions?
That's a really good question. I think I learned a lot, both scientifically and like personally. I think it's a big achievement for the Chinese lunar mission. It's difficult to land on the moon, and especially I am a scientist member of the Chang'e 4 mission. So I know it's quite hard to operate for the backside of the moon. So I appreciate the effort for the engineering team, especially people from CNSA and all the people working on the rocket and the spacecraft and the data processing. And for the scientific part, I think I learned a lot about the interior structure of the moon. Like the rock I showed in my slides, it represents the ancient lunar crust, which is the first time we see on the surface of the moon, and is consisted of a mineral named pyroxene and a mineral of feldspar with very minor percentage of olivine. So the rover is still working, so hopefully we may have more information about the far side of the moon for the lunar crust, maybe possible composition of the lunar mantle, which is much deeper than the crust, and maybe we know more about the environment, like space environment of the far side of the moon. And also there's some very interesting astronomy study carry out for the Chang'e 4 mission, which I didn't quite get into this time.